Welcome to lesson 98. In this lesson, we're going to compare two different box and whisker plots to get information. So watch how I describe the distribution of the data in both box and whisker plots, how I can use averages to analyze the data or to make decisions about the data sets, and finally, how I can even construct a side-by-side box and whisker plot when I'm given multiple sets of data. Let's look at our first example comparing two box and whisker plots, and you can see them here. You can see one labeled afternoon and one labeled morning. And we can see they're both about math test scores, and we're going to look at data between them. Already, you'll probably notice that one has more data, a little lower than the other. So let's look at the context. A group of students believe that depending on the time of day you take your math test, your score is affected. Most students in class believe that when you take the test in the morning, your score will be higher. That's an error. Does the data represented in the box plot support this hypothesis? So this is just a theory. Let's see, does that make sense here? So looking at these two data points, I'm looking at the morning one, and you can definitely see that the morning numbers are higher. They range from, 73 to a 98. To about 98, yep. So that's the first thing I'm noticing for the morning. 73 to 98. For the afternoon, scores range from 55 to, it looks like about a 94. So already you recognize one thing, that most of the scores for the morning definitely are higher. Now, does that mean that you automatically score low for the afternoon? No, there are definitely 25% of kids who score between an 85 and a 94. So 25% did very, very well. But compare that to the data in the morning group. How many scored an 80, I think it's an 83 or higher? Well, here's 25%. Here's another 25%. 75% of kids scored an 83 or higher in the morning. Versus if you look at the afternoon group, 75%, so from Q1 all the way to Q4, scored between 70 and 94. So that's compelling data. So 75% between 70 and 94 versus the morning 75% between 83 and 95. So that's a lot. That's a big cluster. The other thing we can look at is the medians and recognize here's our median score for our afternoon group. It's a 75. So what does that tell us? That tells us half of the students scored below a 75 in the afternoon versus look at our median for our morning group. And our median here is an 88. So half scored between a 73 and an 88 in the morning versus half scored between 55 and 75 in the afternoon. That is also pretty important. So 50% between 55 and 75 for the afternoon. And for the morning, 50% between 73 and 88. So just based on this data, the hypothesis seems to support the claim. The students' hypothesis is supported by the data. The morning group has a higher median 88 versus 75. 75% of morning students scored between 83 and 95 versus afternoon where half scored between 75 and 94. And it's the upper half. Like in both of these, I'm really giving the upper half of the data. And I probably should also name that. And you could also just see the box plot is further to the right, represents higher scores. I want to make sure you could actually see this part over here. Okay, so I just gave a whole bunch of facts that suggest this. Now, will this always be true? No. This is just one data set that is used. And if I wanted to test a hypothesis, I would repeatedly test the data again and again. So hit pause and jot this down, and you can probably even add some more data to as compelling evidence that supports this hypothesis. Denai recorded the number of fish caught by Ayo and Okoye rivers of India, Ayo and Okoye rivers. She wanted to know if there was a difference in where to fish. Her data is represented in the box and whisker plots. So just looking at these two data sets, first thing you're probably noticing is that they have the same range. So they both go from 4 to 16. What else do you see? What else do you notice? Well, the bigger part that I noticed, their medians kind of look close. So between 9 and 10. So, okay, medians are pretty close together. But what do you think it means when the boxes themselves are different sizes? What does that tell you? Well, this tells us our interquartile range is different. And your interquartile range, your IQR, represents 50% of your data. It goes from Q1 to Q3. And when I'm looking at the first one, I notice that it is very small. So this suggests it is clustered. Look at how clustered it is. So 50%, if you go to the Ayo River, I notice that 50% of the time they catch between 8 and 11 fish. Versus the Okoye River, you can catch anywhere from about 7 or 8 fish to 13 fish. So there's a much wider range of number of fish. Let's put these notes in. They have the same range. Similar medians. But different IQRs. The range for the Okoye River is wider, meaning more variability in fish. Okay, so let's have that part in there. And I also kind of want to add, it goes between 7.5 and 13. The IQR is between 7.5 and 13 fish. I want to name that because this context matters. We're talking about catching fish here. 50% of the time, I catch more fish in the Okoye River. So which data set is more spread out? Overall, the range is the same. You can definitely see that. They have the same range. So both range from 4 to 15 fish, but, or 75% of the data for the Ayo River ranges from 4 to 11 fish, while at the Okoye River, it's from 4 to 13 fish. And that matters because it means 75% of the time I get into a higher number with the Okoye River. And that didn't happen at the Ayo River. So which river would you rather fish at? I would rather fish at the Okoye River. And listen to this reason. In the upper quartile, is from 13 to 16. That means like 25% of the time, I'm going to catch between 13 and 16 fish in that river versus the Ayo River, where 25% of the time it's going to be between 11 and 16. Okay, and I'm giving that term upper quartile for a reason. All right, so that's my data, that's my distribution. You can see that even though the ranges are the same for the overall minimum and maximum, that box in the middle really matters. I can see the median is slightly higher in Okoye, and I could also see that my fourth quartile, that last quarter, is way higher. I'm at least getting 13 fish there versus the Ayo River, where that upper quartile is only 11 to 16 fish. That's it for today, Math Marvels. Keep practicing and thinking about what these numbers mean and connect the numbers to the context of the problem. I will see you in the next lesson. Be well.